All right, so if I ask you to use the properties of log, let's start with the fact that we have a square root here. What kind of power is a square root? 1/2. So I could write this whole thing as log base A r cubed s squared t to the 4th to the 1/2. Okay, then think about exponent rules. What would you do with that 1/2? We could distribute that through, so we would have log base A, power to a power you multiply, so that's r to the 3/2, s, 2 times 1/2 is 1, t, 4 times 1/2 is 2. All right, from there, if I want to break this apart, what would I have to do? So breaking apart we talked about yesterday is when you put a log with each piece. What would I need to do there? We have several pieces, we have each variable. On the top, those are multiplied, so what would you do with them when you break it apart? You add the log, so it'd be log base A of r to the 3/2, but where would the 3/2 go? Yeah, so if you didn't recognize that, you might have written it here to start with, but remember, we could go ahead and just drop that down in front. Okay, it was multiplied with this one, so we could do plus. So property from yesterday, when you have exponents, they turn into coefficients. Then, this one was multiplied, so we have plus log base A of s. Then it was divided. So we subtract log base A of t squared, so where would we put the t, or the 2? So, as the expanded form is breaking it apart, like this, we don't have any more exponents or things being multiplied or added. Any questions there? So we're practicing using those properties today. So let's take a look at this one. And this one tells me to write the following as a sum or difference of logarithms. A lot of times you'll just be told to expand, which just means break it apart. So what we were doing, just a more complex expression to start with. So what would we do first? Okay, you could take that square root and it's the same as what? A 1/2 power. So I have x times x squared plus 1 to the 1/2. So I have the log of things being multiplied together. How do I break those apart? Addition. So it's log base A of x plus log base A x squared plus 1 to the 1/2 power. Now, what else can we do? The 1/2 can come down in front. That whole thing is to a power, so I can bring that whole power down. All right, can I break apart the log of x squared plus 1? The x squared and the 1 are being added. We have rules for breaking apart things being multiplied and divided. So can I break them apart if things are added or subtracted? No. Can I bring down the square on that x squared plus 1? No, because it's not the whole parenthesis being squared. It's just one term. So since the square is inside and I can't separate the addition, this is as far as it goes. All right, why don't you guys try B? There wasn't a base written on this log. That's okay. Anytime there's not a base, it's assumed to be 10. If it's not written on the original, you don't have to keep writing it, or you don't have to write it. If there is a base written, you have to carry it through. Now remember, what we're doing here is essentially breaking apart the factors, the things being multiplied or divided. So there's two things being multiplied on top, there's something being divided on the bottom. So we should have 3 different logs at the end. So I have log of x. It was multiplied with x plus 2. So multiplication, when we break it apart, we add the log. So plus log of x plus 2. I'm dividing by this, so I would subtract the log of x plus 3 squared. But we can go one more step. What do? Square comes down. I can't break apart x plus 2, so that just stays. Minus 2 log of x plus 3.
Do you want us to show that step versus
You can do it together. Okay. All right. It looked like we were maybe struggling a little bit with this. A few of you were just staring at your papers when I walked by, so let's do some more. If I said log base 3, x cubed, y squared, divided by w to the 4 z. Right, so if I am telling you to expand this, we are breaking apart the logs. That means anything multiplied or divided gets its own log. How many different logs am I going to have on my final answer? 4. We have 4 different factors here. Okay, so they all get their own log. We have to write the log base 3 on each of them. It was x cubed, so what do I do with the cube? Okay, this was multiplied, so plus log base 3 of y squared. So the square goes to the front. Okay, both the w and the z are on the denominator. So what will I be doing with both of those logs? Yeah. You have a couple different options. So you could say minus and then both of these. And I'll talk about the other option here in a second. So we had log base 3 of w to the 4th, so the 4 comes down. It was multiplied with the log base 3 of z, and it didn't have an exponent. So if you distribute that negative, it's just minus 4 log base 3 of w minus log base 3 of z. So essentially, anything that was in the numerator has a plus. Anything that came from the denominator has a minus. Okay, think about it. The denominator is like a negative exponent. So if you have multiple things being or on your denominator, you'll just subtract each of those logs. Okay, I want you guys to try another one. Try that. Okay, so we have log base 5 of a, the cube root of a squared is what power? 2/3, so a 2/3 comes down. Plus log base 5 of b to the 4th, so the 4 comes down. Both of these are on the denominator, so you could just subtract each of them off, so minus log base 5 of c minus log base 5 of d plus 1 squared, so the 2 goes to the front. One thing, make sure this d plus 1 is in parentheses, so it shows you're doing the log of that entire expression. All right, seemed to do much better that time. Are we okay with this?
Yeah.
Yes.
Why is the log 5c, why is it minus the 2?
Because both of these were on your denominator, so it's kind of like up here, it would be the top minus the entire bottom, and if you distribute that negative, it just makes both denominator terms have a negative. Other questions? Let's go the other direction. So if I give you the expanded form, can we put it back together? A lot of times this might just say condense. Rewrite it so it's only a single logarithm. Basically with this, you have to look, anything that's positive goes on top, anything that's negative goes on the bottom. So log base 4 of x, that was a positive, so x is on top. Minus log base 4 of y, so where does my y go? On the bottom. Plus log base 4 of z. This one's added, so it goes on the top. It's going to be multiplied. So since it had a positive log base 4 of z, that had to be on the numerator. So it's just log base 4 of xz over y. Look at this one. What would I have to do first? Yeah, move the 4 and the 5 into the x. So then we have log base b. R to the 4th, that was a positive, so that's on top. Minus, so we're dividing by s to the 4th. Alright. So on this one, 1/3 turns into an exponent, 2/3 turns into an exponent. So we have log base a. Is my x to the 1/3 on the numerator or denominator? Thank you. Numerator, because it was positive. Plus log base a of y to the 2/3. So it would be times y to the 2/3. This is being subtracted, so where do I put the x, y? Does everybody understand how we're getting these? Why don't you guys try it? I had the log base a written one time. So this was a positive log base a of x, so x is on top, plus log base a of 9, so what am I doing? Times 9. So you can write x times 9, or you can put 9x. Plus, so multiplied by x squared plus 1 minus, so divided by 5. You could choose to distribute the 9x on top, but you don't have to. Either way is fine.
We can leave it as x times 9.
Yeah. On B, what do I do first? Take those coefficients into the exponents, so we get log base 5. Both of these are added, so it's just u to the third, v to the fourth. Do we need more practice with these? Then I have one final type of problem for today. This one is going to ask us to use a given fact to evaluate the logarithm. Okay, so I'm not just asking you to plug this in your calculator, I'm asking you to use the decimal that I gave you. So if I were putting something like this on a test or quiz, you would have to show me enough work that I knew you were actually using your property, not just plugging it in your calculator. So we have to write something down. The fact that we are given is log base 10 of 7 is equal to 0.8451. So if I'm asking you to use that to evaluate log base 10 of 49, do you guys have any suggestions? You can either write it as 7 squared or 7 times 7. If I write it as 7 squared, what do I do? Using my properties. Move the 2. If you wrote it as 7 times 7, you would just have log base 10 of 7 plus log base 10 of 7. So now, I can replace log base 10 of 7 with its decimal equivalent. So that's 2 times 0.8451. And what does that give me? B. Log base 10 of 70. I gave you log base 10 of 7, so how would you rewrite 70? So properties of logs say if those are being multiplied, we can add their logs together. I gave you log base 10 of 7. That's 0.8451. I didn't give you log base 10 of 10. It's 1. It means 10 to what power equals 10? So we get 1.8451. Any issues with this? So we have quite a bit of time left. My hope is that you can get your homework done and not have anything to take home over the weekend. So we're on day 3 of that handout I posted on Classroom.